In this video, we'll look at finding the equation of a least squares regression line on a TI-83 or TI-84 graphing calculator. As we go through, you're going to see a lot of boldface type. That indicates a keystroke. So for instance, this is the stat button, this is the enter button, and so on. Okay, we're going to use these data right here. We've got data on heights and arm spans for 15 of my students from last year. And we're going to use these to see if we can come up with a linear relationship, a best fit line, that would allow us to predict arm span based on the student's height. So the first thing you have to do is put your data into the calculator. So if you have your calculator turned on, you press the stat button, and when you get into the stat button, it'll look like this, and you just press enter to go into the editor. I already have the data copied in, and if I had had data in there to begin with that I wanted to get rid of, the easiest way to do that is to move your cursor up to the top right here and highlight the name of the list, and then press clear and enter, and then you can type in the new data. All the old data will disappear from there. You can store your lists in your calculator, and if you want to keep the data that you already have in there and not lose it, you can store it as a list, and then it'll be saved in your calculator's memory. Okay, to make a scatter plot of these data, what we're going to do is, first thing you do is you go to the y equals screen and make sure that there's nothing in there. If there are any equations in here, you can clear them by hitting the clear button, or you could just move your cursor to the equal sign and press enter and turn the equation off. Okay, since there's nothing in there, we don't have to worry about that. Now you go second y equals, and that puts you into the stat plots, and then you select a stat plot. You can just select number 1 and then press enter to turn it on. Now on the type line, you want the first one right here, so select that, and then here your X list, L1, this represents the heights, and then your Y list represents the arm spans, and that's the way we want it to be, so we don't have to do anything else. If we go zoom 9, the calculator will make the scatter plot for you. Now this scatter plot shows a moderately strong positive linear association between arm span and height, so I'd feel comfortable finding a best fit line for this scatter plot. If my scatter plot were curved, that would be problematical. I would not try to fit a straight line to that. Later on in the course, you'll learn about how to straighten curved scatter plots so that you can go ahead in situations like that. But for now, I would only fit a best fit line to a scatter plot that was reasonably straight to begin with. Now, once you have your data in and you believe that your scatter plot is straight enough to find the equation of a best fit line, you can do that by pressing stat and then cursor over to calc and then select number 8 from the list. It's linreg a plus bx. And if your data are in list 1 and list 2, you can just press enter and the calculator will find the y-intercept and the slope for your best fit line, which would be arm span with a hat equals 28.4456 plus 0.8309 times height. If your data are not in list 1 and list 2, you can tell the calculator where they are. For instance, I've already stored my height and arm span data in my calculator, and if I go stat calc 8, I can now tell the calculator where the lists are that have the data. So I can go to second of stat, and then I can scroll down. I can find my x variable, which is this one. And then I'll put a comma, and then I go second stat, and I go down the list to my arm span data. And there it is. Now the calculator is seeing this as the x variable is the height and the arm span is the y, which is what we want. We want to predict arm span, so that should be the response. Okay, and then you press enter here, and there's your best fit line. Now on this display, we don't have any r squared or correlations shown. If you want to see those, you can go second of the 0 key, and that puts into the catalog, and then you can scroll down to the D's, or you can just press this D button right here and it will take you to the D's immediately, and then you can just work your way through until you see this diagnostic on. You select that by pressing enter once, and then you execute that command by pressing enter a second time, and then you can repeat the regression that we did before. If you go second entry like this a couple times, it'll pull that old command back up, and then when you run the regression, there it is. So you have the regression line plus the r squared and the r. And you see this r is pretty close to 0.9. This indicates a strong positive linear association between height and arm span. And this r squared basically says that 79.04% of the observed variation in arm span is explained by the least squares regression of arm span on height. Now, if you want to store your regression line, that's a little bit more complicated, but not too bad. What you do is you go to Stat Calc 8, and then you can store your regression line by going to the vars key right here, and then go over to yvars. So you're going to cursor over once, and then you press enter to select function, press enter again to select y1, and then press enter again, and now the calculator will store your regression results on the y1 line on your y equals screen. So if you look in here, there it is. That's our best fit line. And then you can use that to make predictions. If you want to see this graphed on the scatter plot, all you have to do is press graph. And there it is. It goes right through the scatter plot, and you can see it looks very nice. Okay, if you want to make a prediction, you can use this y1 that we just stored, and the way you select that and get that out on your screen is you go vars, yvars, function y1, and then you can put in parentheses any x value that you want. For instance, if you want to predict the arm span for somebody whose height was 180 centimeters, you could type in 180 for the x value, and then the calculator tells you that that person's arm span would be predicted to be about 178 centimeters. So the calculator is good at making predictions like that. Now your calculator has this nice feature. It stores the residuals for you. And if you want to see them, you can hit second stat and go into your list of lists. Then you can scroll down to where it says RESID. It's usually pretty far down there if you have a lot of lists in there. You can also scroll up, and it kind of wraps around. You can come up from the bottom of this list of lists, and you press that to select it out. And then if you press enter, it will put the residuals on your main screen, and you can scroll across and look at them. Okay, that's not always the most efficient thing to do, but you can look at the residual values that way. You could also pull the residual list up into your data editor and look at them there. If you want to plot the residuals, you make a scatter plot. Okay, first thing you got to do before you do that is make sure that this regression equation is turned off. So we'll turn that off, and then we'll go up to plot 1, and we will turn this plot on, and we'll set it up as a scatter plot. But instead of our y list being L2 now, I'm going to make the RESID, or residual list, be my y list. So I'm going to go to second stat, and I'm going to go to the residual list, and I'm going to put that in, and then I'm going to draw a scatter plot for the residuals versus the height. And if I go zoom 9 to fit the screen to my values, then I get a residual plot that looks like this. And this is a pretty good residual plot. It shows no discernible pattern, and that's what you want in a residual plot. No discernible pattern. Okay, it should look like a random scatter of points, and it looks pretty good that way. So I feel comfortable with my specification of a linear model for the scatter plot that I have, and the residual plot sort of backs me up on that. Now, there are some residual plots that you don't want to see if you're working with data. Okay, when you do a regression and you get a residual plot that looks like this, it's curved, could be curved that way or could be curved the other way, so that it opens down. Either way, that indicates that a linear model is not appropriate for your data. Same thing here. If you have a residual plot that looks kind of like a wave, that would indicate that a linear model is not exactly what you want, and you might be able to improve on your model specification to fix these problems. And then the third thing that could happen is your residuals could spread out as you go to the right, or perhaps as you go to the left. And you have more spread on one end of your residual plot than on the other. Then your linear model is going to have limited predictive value, And there are ways to fix that, but they're pretty much beyond the scope of what we're doing now. So later on, when we'll get to regression inference, we will look at situations like this where you have curved scatter plots, and we'll figure out how to straighten them out. And then we can use all of the methods that we use with regression inference for our straightened out scatter plots. But that's for much farther down the line.